Hello, Algebros. We are going to do number 5 next. So our first step is always to factor the top and bottom. So step 1, factor top and bottom. So if we do that, the top 4 goes up top, 5 on the bottom. So the factors of 4 that add to 5 would be 1 and 4. So up top we have x. Oh, hold on. Whoop. Those factors will still be right, but I just noticed that we have an x on each of them, so we would factor that x out first. We still have 4 and 5, so our factors will be x times x plus 1 times x plus 4 on the top. And on the bottom, we also have a GCF of 4x. So that would give us x plus 2. Okay, so 4x, x plus 2. All right, so remember, factored form helps us find the holes in the vertical asymptotes. So if we look here at the factors, remember our holes happen when a value of x makes the top and the bottom 0, i.e. they have the same factor on the top and the bottom. So this one's a little bit deceiving because we don't see those big sets of parentheses that are the same. But if x were to equal 0, and you were to sub-0 in here and multiply 0 by anything that equals 0. And if you were to substitute 0 into here, that would make that 0, and then multiply by the parentheses, that would make that 0. So an x value of 0 will create the same value on the top and the bottom. Or we'll create 0 on the top and bottom. And that's because we have a lone x. So if we didn't have that lone x out there, then we would not have a hole. But since we have that lone x, our hole is when x equals 0. And if that doesn't make any sense to you right now, that's fine. We haven't looked at what a hole looks like graphically. Essentially, it's an open circle on the graph. So if you remember doing inequalities at any point, so like x is greater than 2, on your number line you'd have an open circle and then you would shade the values greater than 2. This is essentially what a hole is. The graph does not exist at that point. Oh, that's going to make everything else pop up. Okay. There are no other holes because there are no other shared factors. So now let's figure out what our vertical asymptotes are. Remember, the vertical asymptotes you find by setting the factors of the denominator equal to 0, and it needs to be, your final answer needs to be written as an equation. Oh, so step 2 would be identify any holes. Step 3, find your vertical asymptotes. Okay, so that's what we're going to do. We're going to set our factors equal to 0, so 4x equals 0, and x plus 2 equals 0. So we would divide by 4 on both sides, and x equals 0. Subtract 2, and x would equal -2. So those would be our 2 vertical asymptotes. Oh, wait, sorry. Because we have a hole at 0 already, that would not be one of the vertical asymptotes, so scratch that. So our only vertical asymptote is x equals -2. Sorry about that. And last, find the horizontal asymptote. And remember the horizontal asymptote can be found by looking at the degree of the function. So we're going to look back at the original equation, so not the factored one. Our degree up top is 3 and our degree on the bottom is 2. So n and m, which would be 3 and 2. So what does that tell us? There is no horizontal asymptote. All right, let's take a look at number 6. So our first step would be to factor the top and bottom. So the bottom can be factored. There's a GCF of 3, so 3x minus 2. Next would be identify any holes. That looks like rolls. And the factor on top is 1. There's nothing it shares on the bottom, so there are no holes. All right, next we are going to find our vertical asymptote by setting our factors equal to 0. You only need to set the factors that have an x in them equal to 0. So we're going to add 2, you get x equals 2. And last, our horizontal asymptote. So again, we're going to look at the degree. And there is no x value up top, so that's a degree of 0. So remember, we want to compare n to m. So our n value would be 0, and our m value would be 1. Remember, when there's no exponent right there, we know it's a 1. So our m value is bigger, and when our m value is bigger, it tells us that our y, or the horizontal asymptote is y equals 0. All right, we will go over one more example, and just to tell you right off the bat, that next example is going to have all 3. So far we've had none on all of them. Our next example is going to have a vertical asymptote, a hole, and a horizontal asymptote. So happy mathing.